Hello class, this is lesson 2-7 about using formulas. So to begin, let's just discuss what is a formula. Well, it is simply an equation that expresses a relationship between specific quantities. So you might be thinking of the area formula or some other formula. But let's just start with this equation, 5a minus 2b is equal to 15. We want to solve and get that a by itself. To begin, let's add 2b to both sides to move it away from the a. I'm left with 5a is equal to 2b plus 15. And now to finish, I can divide everything by 5, and I find that a is equal to 2b over 5 plus 3. And that's how I would get a by itself. Here's another equation. Let's solve 4p minus 7r equal to pq plus 16, and we're going to solve it for the variable p. So since p is on both sides of the equation, let's move them to the same side by subtracting pq. So I have 4p minus pq minus 7r is equal to 16. Now we can move that 7r to the opposite side by adding it. So I have 4p minus pq is equal to 7r plus 16. And now I want to get that p alone, so we are going to factor it out. We're left with 4 minus q. Now I can divide both sides by the quantity of 4 minus q. And when I do that, I'm left with p is equal to 7r plus 16 divided by 4 minus q. And that's it. I got the p by itself. So let's go ahead and move on. The area of a trapezoid is a equal to h times b1 plus b2 divided by 2. And we are asked to solve for h. So in case you don't know, the b1 and the b2 are the bases, and h is the vertical height of the trapezoid. So let's go ahead and write out our equation. A is equal to h times b1 plus b2 divided by 2, and solve for h. First step, let's multiply both sides by 2 to get rid of that denominator. I'm left with 2a is equal to h times b1 plus b2. And then I can divide by that quantity of b1 plus b2 to get the h by itself. So when I'm done, h is equal to 2a divided by b1 plus b2. So now that I have the h, we're going to plug in when the area is equal to 70 feet squared, and then also when the bases are 22 feet and 18 feet. So 2 times 70 is 140, and 22 plus 18 is 40. When I divide those, I get 3.5. So this is telling me that the height of this trapezoid is 3.5 feet. And that's it. All right, let's go ahead and move on to a new word problem. This one says, for a party, Maya bought pizza represented by t equal to 13.49c plus 15.49p. T is the total cost, C is the cheese pizzas, and P is the pepperoni pizzas. If she has $85 to spend and wants 3 pepperoni pizzas for this party, how many cheese pizzas can she get? So let's go ahead and write out our equation again, or our formula. T equals 13.49C plus 15.49P. Then we can go ahead and plug in the information we know. The total cost that we have is $85, and I don't know how many cheese pizzas I want, so I'm going to leave that variable. But I know that I have 3 pepperoni pizzas that I want to buy, so I'm going to multiply that by 3. So let's go ahead and rewrite this. So 85 is equal to 13.49C plus 46.47. I can subtract that amount from both sides of my equation, and I am left with 38.53 is equal to 13.49C Final step, let's divide both sides by that 13.49, which is the price of a cheese pizza. And when I do that, I find that with the amount left, I could purchase 2.86 cheese pizzas, which they probably won't let me do. So I would say in the end that Maya would be able to get 2 cheese pizzas along with her 3 pepperoni pizzas. And that's it. All right, let's go ahead and move on now to dimensional analysis. Another term for this is unit analysis, because for this, we are just performing operations with units. For example, your pool will hold 97,285 liters of water. If 1 gallon equals 3.785 liters, how many gallons will it hold? So I'm starting with that 97,285 liters, and I'm going to multiply it by the conversion that I'm given. So since I want to get rid of liters, I'm going to put that on the bottom, and you'll see why in just a moment. So 3.785 liters on the bottom and 1 gallon on top, because liters on top and liters on the bottom cancel the units out. So then I'm left with 97,285 gallons divided by 3.785. And when I do that division, I come to my final answer, which is going to be 25,703 gallons of water. That's a lot. Our next example is asking us to convert 4,000 yards into miles. So some information that would probably be helpful would be the conversion factor of 1 yard equaling 3 feet. And then also just knowing that 1 mile is equal to 5,280 feet. So these are some important conversion rates, and let's go ahead and use them now. So let's write out our 4,000 yards, and we want to get rid of yards. So I'm going to put the yards down below for what I'm multiplying by. So I'm going to put that 1 yard on the bottom, and up above, I'm going to put 3 feet. And now I can cross out the yards. And I don't want to end up with feet. I want to end up with miles. So let's go ahead and multiply by that conversion rate. And let's put the feet on the bottom. So underneath, I'm going to put 5,280 feet. And on top, I'm going to put 1 mile. And so now the feet will cross out, and I'm just left with miles on top. So I can multiply 4,000 times 3 miles, and then on the bottom, I'm going to divide by 5,280. And when I divide those values, I come out with 2.27 miles. So this means that 4,000 yards is about the same as 2.7 miles. Our next example says a recipe calls for 20 fluid ounces of milk. If Nathan buys a half gallon of milk, how many batches of the recipe can he make? So there's a few conversions that we need to know. For instance, we need to know that 1 gallon is equivalent to 4 quarts. Also, 2 pints is equal to 1 quart. 1 pint is equal to 2 cups. And then the last conversion that we can use in this one is that 1 cup is equal to 8 fluid ounces. Okay? So what I think that we should do is convert the half gallon of milk into fluid ounces. So if I have a half of a gallon, let's go ahead and get rid of gallons. So I can put that on the bottom, and I know that 1 gallon is equal to 4 quarts. And now I can cross out the gallons. So now let's go ahead and convert quarts. So on the bottom, I know that 1 quart is equal to 2 pints up above. And I can cross out quarts. And then let's see here. I know that 1 pint on the bottom is equal to 2 cups on the top. And this way I can cross out the pints. Final conversion, I can multiply by 1 cup on the bottom and 8 fluid ounces on the top. And then that will eliminate the cups. So let's see what we need to multiply. 0.5 times 4 times 2 times 2 times 8 fluid ounces. And since the denominators are 1, I don't need to worry about that. So when I multiply, I come out with 64 fluid ounces, and that is what is equivalent to the half gallon. But remember, I want to know how many 20 fluid ounces can fit into that. So I'm going to divide it by 20 fluid ounces. All right, and when I do that, I come out with 3.2, and the fluid ounces cancel out. So this means I can make 3.2 batches, but we're just going to go with full complete batches. So Nathan can make 3 batches of his recipe, and that's it. All right, let's go ahead and move on to our last word problem. This one says that in Japan, a marathon runner ran 16.5 kenjaku per second. The Olympic marathon record is 26.2 miles in 126.5 minutes. Did the Japanese runner beat the Olympic record? Well, here are some formulas that might be helpful. D equals RT, that stands for distance, is equal to rate times time. It might also be beneficial to know what is a kenjaku. So 1 kenjaku is equivalent to 10/33 of a meter. Okay. Additionally, since I want to know it in miles, 1 mile is equal to just about 1,609.344 meters. All right, so now with that information, let's go ahead and figure this out. We need to convert that 16.5 kenjaku per second into miles per minute to see if it is faster than the Olympic marathon record. So here we go. 1 kenjaku is equivalent to 10/33 meters. So we can cancel out the kenjaku, not worry about that anymore. But meters, we can put on the bottom. So 1,609.344 meters is equivalent to 1 mile. And now I can cancel out the meters. Moving on to seconds, I know that there are 60 seconds in 1 minute. So I'm going to put the seconds on top because it's already on the bottom. And this way I can cancel out the seconds. And there we go. Now let's go ahead and see what we need to multiply. 16.5 times 10/33 times 60 miles is the units left over. And then on the bottom, I need to divide by 1,609.344 minutes. Okay? So when I go ahead and multiply these values and do some division, I'm left with 0.1864 miles per 1 minute. Since I want to know what this would be for 126.5 minutes, I'm going to multiply those values. That'll cancel out the minutes, so my final answer now would be in miles, and it's only 23.6 miles, which means that this Japanese marathon runner still did not even run as many miles as the Olympic record. So our final answer then, we can say that the Olympic record is still faster than this Japanese runner. And that's it. So I hope that this lesson made sense. I have 2 problems for you to try on your own. So go ahead and do those and then ask me any questions when you come into class.